In this video, we're going to continue with our calculations of the sources of variation related to the regression analysis. So in the previous video, we ended up by calculating the squared deviations related to our regression model, our regression equation, and we calculated the sum of squares for that source of variation. We have two more to go, and that's the sum of squares of the residual or the error related to our regression analysis and the total. So I'll start with the sum of squares residual, and I'm just going to type in the squared deviations for the residual term. I'm going to tab over here, and I'm just going to put the heading for the squared deviations for the total. And the total is just simply the sum of the prediction of our regression model, which include the two coefficients, plus the error related to the prediction. And so that's the first one we're going to start with here. So we need to calculate the squared deviation. And if we take a look inside this equation, we're calculating the difference between the actual observed value and the predicted value for each individual participant in our study. So I'm going to active this cell here, I2, and I'm going to hit the equal sign, and I'm going to shift 9, so I'm going to open parenthesis here, and I need to find the first Y value, the raw data here, and that's for participant 1 in C2. So that's the first observed value, and I'm going to hit the dash, and I'm going to subtract the predicted value that we generated in the previous video. I'm going to shift 0, shift 6 for the square. I'm going to raise that to the power of 2 and hit enter. Now, as opposed to what we've had to do earlier, we don't have to use the dollar signs here, because when I pull this cursor down and ask Excel to perform the rest of the calculations, I want to calculate the difference between the raw value and the predicted value matched to each participant. So I'm just going to grab all those. I'm going to pull down, and we have all the squared deviations for the residual term. I need to add all of these up, so I'm just going to click the previous sum, and I'm going to pull this over, and now I have the sum of squares for the residual term, and let's go ahead and do it for the total. So our total sum of squares, we calculate that by first taking the difference between the observed value and the average value for our criterion variable. And so I'm going to hit the equal sign, shift 9, and I need to look for the raw value for the first participant, and that's this one right here. I'm going to hit the dash to subtract the average, which we had calculated earlier. Shift 0, shift 6, I'm going to raise that to the power of 2, and I hit enter. I'm going to grab this cell here. Now here I do have to type in the dollar sign because I want to lock in the average value while allowing C2 to change to C3, C4, C5, so on and so forth. So I'm going to shift 4, I'm going to move over, shift 4 again, so I'm going to lock in C13 and hit enter. Of course this value doesn't change, but I'm going to grab all these, pull these down, and I'm going to calculate that sum. Now the next step here is to calculate the degrees of freedom related to our three sources of variation. And what I'm going to do here is I'm not going to ask Excel to calculate anything. I'm just going to type in what we need to do, what we need to consider for the degrees of freedom, and then we'll enter that in for the next step. Now the degrees of freedom related to the model is always going to be 1 in this case. And the reason that it's 1 is because we only have one explanatory variable. We only have one predictor variable in our model. And so we're just going to leave it as such. The calculation of the degrees of freedom for the residual term is always going to be n minus 2. Now, n refers to the sample size, and that would be 11 here. And 2, we put in 2, we subtract 2 for the number of coefficients in the model. And so in this particular model, we have 2 coefficients. The sum of squares for the total is going to be an n minus 1. Sample size minus 1. So the next step is to calculate the variances for each of these in the mean square. So I'm just going to pull this over here, and the mean square, or the variance, for the model is going to be equal to the sum of squares divided by the degrees of freedom. In this case, the degrees of freedom is 1, so I'll just go ahead and type in a 1, and it's going to be the same value. But it's a good habit to get into that equation because the form of the equation is the same all the way through. And so let's calculate the variance, or the mean square, for the residual term. And that's going to be equal to the sum of squares / divided by n minus 2. So I'm just going to go ahead and do this calculation mentally. We have 11 participants in our study. Subtract 2 is a 9. So I'm just going to go ahead and type in the 9 and hit enter. And we have our mean square, or our variance, due to the inherent variability in the data, the differences between the actual value and the predicted. And lastly here, we'll go ahead and calculate the mean square for the total. And that's going to be equal to the sum of squares divided by, in this case, 10, because 11 minus 1 is a 10. And we now have our variances, which I'm just going to bold to highlight this, that we will then use to determine if our model is considered to be statistically significant. So we'll do that in the next video to close out our regression analysis.